Okay, number 16 on the worksheet. 6 foot tall man walks at a rate of 4 foot per second toward a street light that is 16 feet above ground. So here's the street light. So here's a 6 foot man. Six foot. And you can see the shadow, right? So here's the shadow right here. At what rate is the length of the shadow changing when the man is 8 feet from the base of the light? Okay, now remember, all rates are relative to points. So let's read it again. 6 foot man walks at a rate of 4 foot per second. So the man here, 4 feet per second, relative to a fixed point. Of course, we want to use the light pole, so we'll call that this distance right here. That's his distance towards the light pole. It's changing 4 feet per second, so that's dx dt. Okay. At what rate is the length of the shadow? Where's the length of the shadow? It's right here. Right? From the man to the tip of where the light hits the ground, making a shadow. You can envision that. So that's what I want. When he's 8 feet from the base of the light, that must be x, huh? Right, good so far? Remember, you can pause me whenever you want. Okay, now we got to come up with an equation. So we've got the given rate, the want rate, and the when. We got a picture. We got the changing variables. See, you don't need a variable along this slant line because there's no information about it at all. You don't need it. So you might be thinking Pythagorean theorem, but that's not going to work. In this case, we're going to need similar triangles. So we got the big triangle, see it? 16 by, what's the base of the big triangle? Can you guess? X plus y. So the big triangle is 16 over x plus y. And the little triangle is 6 by y. Now you heard me say it many times. Simplify these equations. So I'm going to cross multiply. Clean this up. Get rid of the fractions. You don't want to be doing a quotient rule here. So cross multiply. So 16y equals 6 distributed, right? Take 6 times this will be 6x plus 6y. Subtract the 6y to the left side. That makes sense, doesn't it? Look how it's cleaning up. Divide by 2. Yeah, there you go. I like that much better. So now we're done. Now we're down to about step 4 or 5. I can't remember. I don't have those notes with me here at home. But we're at the point where we're ready to do the derivative, the implicit derivative. So does my equation here have the letters from the rates? Yes. A dx and a dy, there's an x and a y, we're ready to go. There's no extra variables either. So take the derivative. What's the derivative of y? dy dt. And then the constant stays put. What's the derivative of x? dx dt. See, that was a fairly easy one, really. There's no powers or anything. Okay, now when you plug in, well, you can plug the dx dt in, that's 4. We don't have dy dt. Interesting. Normally we'd plug the 8 in as well, right? But guess what? There's no place to plug it in. It must not be dependent on where he's at. So we're done here. dy dt is going to be 3 times 4 is 12 divided by 5 feet per second.